Balancing equations. You guys have done a lot of balancing this term already, or this year. So when we had area of the circle and we had pi r squared and I gave you the area and you had to solve for r, or different times in Pythagorean theorem when you were given the hypotenuse but you had to solve for the leg. So you've already done some complex multi-step balancing because you had to take square roots and move things around. This time we're just going to practice the balancing when it may not have a specific context like measurement or geometry. So here we've got the left side of the equation and the right side, and we have to keep them balanced. If you think about this as a scale, right now they're level and we need to keep them that way. So we need to subtract 12 from this side and 12 from this side. So we have 3x plus 12 subtract 12, 24 minus 12. 12 subtract 12 is 0, so it's gone. 24 subtract 12 is 12. And now what operation is happening to the x? Well, 3 and the x together, that's multiplication, so the opposite of multiplication is division. I'm going to take 3 divided by 3 is 1 whole. So now x is alone, and that's your goal, is to isolate. It's another vocab you might hear is isolate the variable rather than balance the equation. Isolate the variable. And then what we did to that side, we have to do to this side. So 12 divided by 3 is 4. I can always check it, and I do 3 times 4, so my left side of my equation, plus 12. 12 plus 12 is 24. The right side of the equation was already 24, so left side equals right side, and it's balanced. This one's another two-step. The operations happening to the variable are multiplication and subtraction. So the opposite of subtraction is plus 8 plus 8. 4n subtract 8 plus 8 equals 20 plus 8. 4n negative 8 plus 8, or 8 subtract 8, is 0. This is 28. And now I need to divide both sides by 4. We have n, and then does 4 go into 28? Because now that we're comfortable with our fractions, even if it didn't go in, you can either get a fraction or you can use a decimal. So it goes in 7 times, and we can do our check. 4 times 7 minus 8. 7 times 4 is 28. Subtract 8 is 20. So left side, right side is already 20, we don't have to do anything to it. So left side equals right side. Where it's going to start getting a little bit more complicated, but nothing too intense, is if we have something like this. So now we've got a lot happening on both sides of the equation. It's not just one solid answer. But we do have a variable in common. So this x and this x, we can group them together the same way we would do constants or quote normal numbers. So first, and again, this is where the term isolate the variable comes in. We want to get x by itself, and we want to get all the x's together. So I'm first going to deal with the 12. How do I get rid of 12 on this side? Well, I'm going to subtract it, and I'm going to subtract it since it's being added originally. So 8x plus 12 minus 12 equals 3x plus 2 minus 12. So that is going to disappear. I have 8x equals 3x, 12, 2 subtract 12. Again, got to think about our integers, adding the opposite. So that's going to be, you can either write subtract 10 or it's plus negative 10. Okay. And then we still need to get this, we need the 3 out of here. So if you have 3 groups of something, how do you get rid of it? Well, you're going to subtract the 3 groups of something. And what you do to one side, you've got to do the other. So I have 8x, and it's important to keep the order of your numbers, especially when you're working with subtractions and negatives. 3x subtract 3x is gone, it's 0, and you have negative 10 on this side. So if you have 8 groups of something and you subtract 3 groups of something, you have 5 groups of that something left. The operation between the 5 and the x is multiplication, so we divide it. Negative 10 divided by positive 5 is negative 2. And then we're going to do our check. So we have 8 times negative 2 plus 12, that's our left side. Our right side is 3 times negative 2 plus 2. We'll follow our BEDMAS. Negative 16 plus 12, negative 4. Negative 6 plus 2 is negative 4. So our left side is equal to our right side. I'll run through one more kind, and let's see if we have 4x subtract 12 all divided by 3 equal to 15. So again, my goal is to get the variable alone and isolate it, but first I have to deal with this divide by 3 because it's happening to both these terms. It's happening to 4x and it's happening to 12. So I want to multiply by 3. And remember, this is 3 over 1, and we know 3 over 1 times 1 over 3 is equal to 3 over 3, which is equal to 1 whole. So it's going to cancel itself out. And we're going to times this side by 3. So now I have 4x minus 12 equals 45. And now it looks like everything we've had before. We're going to add 12 to both sides. So 4x equals 57 divided by 4. Now this answer depends on what your textbook or your teacher is looking for. Do they want it in fraction form? Do they want it in decimal form? So if we're going to put it into fractions, so how many times does 4 go into 57? It goes 14 and some amount. So we have 56, so 14 and 1/4, which means my decimal, if I went on my calculator and did 57 divided by 4, means this is going to be 14.25. 57 divided by 4, 14.25. So both these represent the same answer, it just depends which form your teacher's looking for. And again, we can check it. And we have 4. We'll use decimals for this, but it can be solved with fractions. You all know your fraction rules. So 4 times 14.25 is 57. Subtract 12 all over 3. And again, I'm using my BEDMAS rules. And remember, this long division sign really means that there's a set of brackets up top, that you have to do everything in your numerator before you can divide, because this 3 belongs to every term above it. So 57 subtract 12 is 45 divided by 3. 45 divided by 3 is 15, and that's what our right side was equal to. So now we know we've balanced.